Okay, so we're going to finish looking at our Unit 2 review. You should have filled out everything up to Aufbau's principle. So we left off with the SPDF blocks. Now, Aufbau's principle means that when you're filling electron configuration, you want to start with the lowest energy possible. That's your 1s. And then you build up off of that. Remember, the periodic table is arranged according to Aufbau's principle. Hund's rule means that when you're filling the S and the P sublevels, you put one electron in each orbital before you pair up. That's like riding a bus. You're going to sit in the seat by yourself before you sit in the seat with a stranger. Pauli exclusion principle says that 2 electrons can go in each orbital as long as they have opposite spins. But we show that by drawing one arrow up and one arrow down. Now, I can't really do orbital notation on the computer, but I can go ahead and show you that for bromine, the orbital notation would look like this, and then just some reminders. Here they show it as boxes. We usually just draw a line, and those lines, or the boxes here, represent orbitals. The arrows represent electrons. The large numbers represent the energy levels, and then the letters represent the sublevels. So it doesn't matter if it's 1s, 2s, 3s, or 4s. There's always one orbital for the S. 2p, 3p, or 4p, it's always 3 orbitals for the P. D is always 5 orbitals. To write the electron configuration, this is where we take the orbital notation and we shorten it. So we would say it's 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and then remember when you get to the D block, it's one less than the row it's in, 3d10, and then we're back to the row, 4p, and then bromine is the 5th one in there. So here, the large numbers still represent the energy levels. The letters still represent the sublevels. And the superscripts, or exponent, represent the electrons. Okay, we can take that and we can shorten it even more. If we look on the periodic table for the noble gas that comes before bromine, that would end on the 3rd energy level. So we're kind of like taking away all of this, 1s2, 2s2, 2p6, 3s2, 3p6. And so we can put the noble gas that comes before bromine, which is argon, and we can just put it in brackets, and that takes care of all of those inside electrons. And then we just have to add on those last few electrons. So we start on the row that bromine's on, which is the 4th row, and we would say 4s2, 3d10, we're at zinc, and then 4p5 puts us at bromine. For number 23, we're looking at valence electrons. The valence electrons are the outermost electrons, so the highest energy level of A is 4. So if we just focus in on 4s2, how many electrons are there? There's only 2 there, so there are 2 valence electrons. If we find this on the periodic table, and you can do that 2 ways, you can add your exponents or your superscripts, 2 plus 2 plus 6 plus 2 plus 6 plus 2 plus 6. Or you could go to the 4th row, 4s2 puts you at calcium, and then keep going, 3d6, and you're at iron, which is Fe. And then how many electrons will it gain and lose? Since iron is a metal, it will always lose electrons. How many is going to vary because it's a transition metal. For letter B, you can look on the periodic table and see that neon has 10 protons, so it would have 10 electrons, and then you can add 10 plus 2 plus 4, or you could go to the third row, do 3s2, which is magnesium, and then keep going straight across 3p and count the fourth element over, and your sulfur, which is S. I forgot to do the valence electrons. So 3 is the highest energy level, so we're looking at both of these together. So 2 plus 4 would give us 6 valence electrons. You could have also figured out that it was sulfur. Sulfur is in group 16. Last digit is 6, so it has 6 valence electrons. Since sulfur has 6 valence electrons and it needs to have a total of 8, it's going to gain 2 electrons, and so it forms a 2- charge. Right, then we get into our math. Here is another view of that roadmap that I have drawn, and you should have in your notes. You can go back to Unit 2 and look at converting those lessons in the module if you would like to see the way that I wrote it originally. And so we're going to work out some examples down here. So the first thing you want to do is decide how many steps it's going to take. In letter A, it's going to be 1 step. And we know it's a 1-step conversion because mole is part of the question. So we're going to set up our table. Now, since I'm doing this on the computer that has the outline, just think about that outlined box not being there. Remember, you always start with your given. So 4 moles of CuCN2. And then what we want to do is we want to take everything that's not the number, so the unit and the substance, and we want to bring it diagonally down to the bottom so that it will cancel. Once you're at mole, when mole is on the bottom, you can go anywhere on the roadmap that you want. So we're here at mole, and we can go anywhere that we want to go. The question is asking us to go to molecules, so we're going to go this direction to molecules. So we will put molecules of CuCN2 on the top. And then we just have to think about our numbers. So if you look on page 1 of your reference tables in that first box, 1 goes with mole. Molecules is a part of IPAM, so that would be Avogadro's number. And then that's all we have to do. So remember, when numbers are side by side, we multiply, and when they're top and bottom, we divide. So we're going to take our handy dandy calculators, and we're going to say 4.00 times 6.022 special button 23 divided by 1 and hit enter. We want 3 significant figures because of our given. So our answer would be 2.41 times 10 to the 24th molecules. All right, let's look at another example. Here, this problem, if you notice, if you read the question, there's no mention of the word mole. So this is a 2-step problem because mole is not part of the question. So we're going to have to go through moles to get our answer. So we're going to create our table that has 2 steps. We're going to start with our given because we always start with the given, 24 grams FeF3. And then we are going to pull that unit and substance diagonally down to the bottom. If mole is not on the bottom, you have to put it on the top. So we're going to put mole FeF3 on the top. And then remember, 1 goes with mole. Grams goes with mass. So we're going to look on the periodic table. We're going to find iron, 55.85, plus 3 fluorines, which are 19 each. And so that gives us a total mass of 112.85. Now, we don't want moles, so that's where we have to have our second step. So we're going to go ahead and copy that unit and substance again and bring it down diagonally to the bottom. When you have mole on the bottom, you can go anywhere you want on the top. We want to go to molecules. 1 goes with mole. Molecules is a part of IPAM, so we would put Avogadro's number. And then we're there where we want to be. So we're done. So we're going to multiply, divide, multiply, divide. So take your handy dandy calculator and you're going to say 24 times 1 divided by 112.85 times 6.022 special button 23 divided by 1, and then you can hit enter. And you should end up with 1.3, we only need 2 sig figs this time, times 10 to the 23rd. Don't forget about that times 10 there. Molecules FeF3. For letter C, if you read the question, you see the word mole there. So this is one step because mole is in the problem. So we're going to create our table so that there is one step. Always start with your given, 5.600 moles of C6H6. And then what we can do is take our unit and substance and bring it diagonally down to the bottom. You have mole on the bottom. You're allowed to go anywhere you want on the top. It's asking us for mass. So what unit do we measure mass in? We measure mass in grams. So we're going to put grams of C6H6 on the top. 1 goes with mole. The molar mass goes with grams. So we're going to add 6 carbons plus 6 hydrogens. And you should end up with a mass of 78.108. And then that's it. So we're going to multiply and divide. 5.600 times 78.108 divided by 1. We need 4 significant figures this time, so it's 437.4 grams of C6H6. All right, letter D. We have, if you read the question, no mention of the word mole. So this is going to be a 2-step problem because mole is not in the problem, not in the question. So we're going to go ahead and insert our table for 2 steps. Always start with the given. And then we can take our unit and our substance diagonally down to the bottom. Because this is not mole, we have to put mole on the top. Remember, 1 goes with mole. A for atoms is a part of IPAM, so we're going to use our Avogadro's number. Now we don't want moles, we want grams, so we're going to do that one more time. We're going to take that unit and substance, bring it down diagonally to the bottom. When you have mole on the bottom, you can put whatever unit you want on the top, which in this case is grams. 1 always goes with mole. Grams would be the mass of silver on the periodic table. So we look on the periodic table and the mass is 107.87. And then we can multiply and divide away. So we would say 2.3 special button 24 times 1 divided by 6.022 special button 23 times 107.87, divided by 1. We want 2 significant figures. So 411 becomes 410 grams of Ag. All right, and then our last problem we're doing together. If you look, there is mole in the problem, which means it is a 1-step. So we're going to insert our 1-step table. We always start with the given, 36.0 grams of water. We're going to take our unit and our substance and bring it diagonally down to the bottom. Because mole is not on the bottom, we have to put mole on the top. One always goes with mole, and then the molar mass goes with grams. So we're going to add 2 hydrogens plus an oxygen, and that is 18.106 grams And then we can just multiply and divide. So 36 times 1 divided by 18.106. We want 3 significant figures, so that would round to be 2.00 moles of water. All right, now it's your turn. Try those problems, and then you can check your answers.